Hello. So today let's discuss the volcanoes again. And as we've said before, the volcanoes are the waste and recycle system of our world. They're the vents to the underworld. Some ancients used to refer to these as their gods. They would even drop offerings like gold, and there were tales of animal sacrifice. That's true. Nowadays, they still leave offerings like leaves, vegetables, incense, candles, crystals are some of the offerings that people still do. So let's talk about a dirty thunderstorm. I hadn't heard of it before, so it was new to me, but I'm going to share some interesting stuff about it. A dirty thunderstorm is also known as volcanic lightning. It is a weather phenomenon that is related to the production of lightning in a volcanic plume. Well, how does that occur? Triboelectric charging from fragmentation of rocks near the vent and within the plume of a volcano during eruption offers another mechanism for electrical charging. A study in the journal Science indicated that electrical charges are generated when rock fragments, ash, and ice particles in a volcanic plume collide and produce static charges, just as ice particles collide in regular thunderstorms. Volcanic eruptions are sometimes accompanied by flashes of lightning. However, this lightning does not descend from the storm clouds in the sky. It is generated within the ash clouds spewing from the volcano in a process called charge separation. So, what's charge separation? It is the process of an electron in the atom being excited to a higher energy level by the absorption of a photon and then leaving the atom to a nearby electron acceptor. This is what happens at the CERN facility, specifically relative to the reaction plane in PB collisions in the ALICE reactor. With different plumes studied, when they started going downwind, it seemed to have a life of its own and produced some 300 lightning bolts. The implication was that it had produced more charge than it started with. A study performed in 2010 found that the water content of volcanic plumes is much greater than the water content of thunderstorms. The study also found that there may be a needed amount of concentration required in a plume for lightning to occur. Naturally occurring radioisotopes within ejected rock particles may cause self-charging of volcanic plumes. So, what are radioisotopes? They're any of several species of the same chemical element with different masses whose nuclei are unstable and dissipate excess energy by spontaneously emitting radiation in the form of alpha, beta, and gamma rays. During an eruption, a large amount of fragmented subsurface rock is ejected into the atmosphere. A study conducted on volcanic ash from Iceland volcanic eruptions found that both samples possessed a natural radioactivity above the background level. At CERN, the same process is used in the Isolid Radioactive Ion Beam Facility, located at the Proton Synchrotron Booster, the PSB. The physicists investigate the structure of the nucleus. They explore new regions of the nucleus chart and study the abundance of chemical elements in the universe. They are currently aiming to expand from its core low energy science to a high energy, and they say that's nearly complete. Currently, Isolid takes half of the protons produced at CERN from the PSB and fires them into a target to produce radioactive isotopes. This is the same process I'm talking about with volcanoes. So, back to the volcanoes. The height of the ash plume appears to be linked with the mechanism which generates the lightning. The taller the plume, it appears that the larger concentration of water vapor are contributing to lightning activity, while the smaller plumes appear to gain more of their electrical charge from the fragmentation of rocks near the vents of the volcano through charge separation. The atmospheric temperature also plays a role in the formation of lightning. Colder temperatures will create greater amounts of ice inside the plume, thus leading to more friction and electrical activity. In a study presented in the Bulletin of Volcanology in 2010, it was stated that more eruptions with lightning were reported in winter than in summer. This finding indicates that the lightning activity is driven by magma-derived water rather than atmospheric water. It has been suggested that a byproduct of volcanic lightning are lightning-induced volcanic spherules. These small glass spherules are thought to be formed during high-temperature processes such as cloud-to-ground lightning strikes. The temperature of a bolt of volcanic lightning can reach 30,000 degrees Celsius. When this bolt contacts ash particles within the plume, it will cause them to melt and then quickly solidify as they cool, forming orb shapes. The presence of volcanic spherules aids in providing evidence for the occurrence of volcanic lightning when the lightning itself has not been observed directly. So, let's take a moment and relate this to our grid and our map and try to simplify it a bit for people to understand. So, to do that, I decided to place these volcanoes on the map with the grid overlay so we can see why this happens. So here we can see that these fall, a lot of them directly on the grid. So I thought that was pretty interesting, and it made me want to, look a little further and try to be able to show you guys the cause. So then I compared it to particle accelerators. Okay, so in this next picture, you're seeing the two of them compared side by side, and I've also circled the areas where there are accelerators and wanted to show how on each side there are these volcanic vents. So that's about all I have. So at this point, I'm going to hand it over for a technical breakdown and decoding of all of this information by FPV. Thank you. Have a good day.